Welcome to lesson number 2, categories and properties of elements. Our lesson objectives: differentiate between different groups of elements, identify the properties specific to each category of element, and classify elements as metals, nonmetals, and metalloids, and determine their properties. So looking at the periodic table, the general breakdown or classification are metals, nonmetals, and metalloids. And there's a staircase that is in bold on your reference table, and that separates the stuff over here, which are the metals. Everything on the right hand side are the nonmetals, including hydrogen over here. And then the ones that are resting on the staircase and the two in the center below the staircase are called metalloids. So now let's look at the element groups. Group 1, which are these elements here on the periodic table, are called the alkaline metals. They all have, if you look at the electron configuration, they all have one valence electron. They all form +1 ions by losing one electron. They're all extremely reactive with water, and as we go down the group, they get more and more reactive, with francium being the most reactive. Group 2 are called the alkaline earth metals. The way that I remember Group 1 and Group 2 is that Group 2 has two names, alkaline earth, where Group 1 is just the alkaline metals. If you look at Group 2 valence electrons, they all have 2 valence electrons, and they all lose 2 valence electrons to form +2 ions. And these are also fairly reactive in water, but not as much as Group 1. Groups 3 through 12 are the transition metals. These are the elements that are in the center of the periodic table. These are the least reactive metals. This is where we find our precious metals like gold and silver, and they tend to form colored ions in solution. So when we put these ions into solution, forming an aqueous solution, they tend to be colored, like this copper solution here. Group 17 are called the halogens. If you look at their configuration, they all have 7 valence electrons, and they all gain 1 electron to form -1 ions, and these are the most reactive nonmetals, with fluorine being the most reactive. So unlike the metals, they actually increase reactivity as you go up the group. And lastly, we have group 18. These are the noble gases. These are all unreactive, or we say they're inert. It means they don't form or react with anything to form compounds. And they are stable. They say they have a stable octet, meaning 8, so 8 valence electrons. The exception is helium, which is a stable duet. It only has 2 valence electrons, and that is stable. And all of the noble gases are always monoatomic. Mono meaning one, atomic meaning atom. So they're always by themselves. Again, they're not going to be found in compound form. And then hydrogen is not officially part of any group. It is a nonmetal and is a gas at STP, and that's why it is pulled off the periodic table and is not attached to group 1. So let's check your understanding. Can you differentiate between different groups of elements, and can you identify the properties specific to each category of element? Now let's look at the properties of each classification for metals, nonmetals, and metalloids. Metals are malleable, which means that when we hit them, we can hammer them flat, or we can roll them into thin sheets, as you can see here. And they're also ductile, which means we can kind of pull them or draw them into wire, like the copper wire in this picture. They are excellent conductors of both heat and electricity. They have a shininess to them, which we call luster. And all metals lose electrons to form positive ions called cations. And all metals are solid at standard temperature and pressure, except for Hg, which is mercury, and that is a liquid at STP. So why are metals malleable and ductile? Why, when we hit them, they don't break and they actually just bend, or we can pull them into wire? Well, metals consist of layers of atoms that can kind of slide over each other. So here is a metal. These are the metal atoms, and you can see that they're sliding past each other, and they still keep their connection and that's what allows them to still be together, but just be kind of pulled into a wire, as in the picture here, or kind of hammered flat into sheets. Metals are said to have what is called a sea of mobile electrons, meaning the valence electrons are mobile, they're moving, and this allows for electrical conductivity. So if these are all different atoms of the same metal, these electrons are mobile, moving around, and that allows for the conduction of electricity through the metal. Metal alloys are things like brass, which is a mixture of copper and zinc, are much harder than their original metals. This is due to the irregularity in the structure, which helps that slipping and stops it. So if you look here, these irregularities stop the slippage of, or the metals sliding past each other, and makes it harder. What are the properties of the metalloids? The metalloids, or semi-metals, these have properties of both metals and nonmetals. We call them semiconductors. They're pretty good or moderate at conducting heat and electricity. They tend to have luster like metals, so they're shiny, but they're brittle like nonmetals. And silicon, being one of the more important metalloids, is used for making computer microchips. And lastly, let's look at the properties of nonmetals. Nonmetals are the exact opposite of the metal. So if you've memorized the properties or understand the properties of metals, then nonmetals are opposite. They are poor conductors of heat and electricity. They are brittle, which means they will shatter when we hit them. They are not shiny, they are dull. And they tend to gain electrons to form negative ions called anions. Let's check your understanding. Can you classify elements as metals, nonmetals, and metalloids and determine their properties? At this point, you should be able to differentiate between different groups of elements, identify the properties specific to each category of element, and classify elements as metals, nonmetals, and metalloids and determine their properties.